This tutorial video is going to go through the algebra review worksheet that we did at the very beginning, and it will go through each example, basically each section at a time. So if you need to skip to number 11, for example, just go ahead and skip on to that, skip ahead in the video. Alright, so we're solving equations. Here we have a fraction, but remember I'm going to start by getting all of my constants on one side, so I'm going to subtract 3 from both sides. When I do that, I've got 1/2 x equals 7 minus 3, which is 4. And again, I've got 1/2, which is the same thing as x over 2, right? It just has an invisible 1 in front of it. This is 1/2 x, so in order to get rid of that or undo that, I'm going to multiply both sides by 2. 2 times 1/2 is 1, so that's why that cancels out. And I've got x equals 8. So my answer for this one is 8. Another fraction, I'm going to combine my like terms. So I'm going to add 5 to both sides. Got 1/4 x equals 3. And again, multiplying by 4, because 1/4 times 4 becomes 1. So 1x equals 12. Continuing with solving equations, I'm combining like terms. So I'm going to combine my 2x and my negative 4x to become negative 2x. I just combined these. And then I'm going to combine my 3 and my negative 7 to become negative 4 equals 11. Add 4 to both sides. Negative 2x equals 15. And then divide both sides by negative 2. X equals negative 15 over 2. And you could make that into a mixed number, or in this case, since the decimal terminates or ends, you could also use the decimal, but I like to leave them as improper fractions. So negative 15 over 2 is your answer there. Subtract 2x from both sides. And I have 3x plus 8 equals negative 16. Subtract 8 from both sides. 3x equals negative 24. And divide both sides by 3. I end up with negative 8. Combining like terms on the same side of my equation, I get 2x, positive 3 and negative 1, plus 5 equals, and then combining like terms on the same side, 4 and 17 is going to be 21. I'm going to move my 5x to the other side by adding it. So those cancel out. I've got 7x plus 5 equals 21. Subtract 5 from both sides. 7x equals, and I have 21 minus 5, so that's going to become 16. Divide both sides by 7. You get 16 over 7. So in this case, please leave that as a fraction, an improper fraction or a mixed number, but please do not make that a decimal. I'm going to distribute here. 2x plus 8 equals 6x plus 24. Move my variable to one side. And I get negative 4x plus 8 equals 24. Subtract 8 from both sides. Negative 4x equals, and I've got 24 minus 8, which is 16. And then dividing both sides by negative 4, I get negative 4. $20 equals 5 over x. So this one's a little bit trickier because I have the variable on the bottom instead of on the top. So it's kind of up to you. One way you could do this is to create a proportion. So you've got, proportion. So you've got 20 over 1 equals 5 over x, and then you could cross multiply. Okay. So we'll go ahead and do that. That's probably one of the easiest ways to do it. So you get 20x equals 5. Divide both sides by 20, and you end up with 5 over 20, which is 1 over 4. This one is already a proportion created for you, so you can go ahead and cross multiply. 7 times 4 is 28. 2, remember you're distributing this 2, so 2 times x is 2x. 2 times 2 is 4. Subtract 4 from both sides. 24 equals 2x, and then divide both sides by 2. X equals 12. Alright, on to finding the average, and this really goes kind of to the solving equations that we've done. And there's really two ways to do this, sort of the algebraic way and the non-algebraic way. We'll do the algebraic way first. Remember, to find the average, I add all my scores together and divide by how many there are. So we've got 5 test scores, and we know that the average of all of them is 78, but we only know the average of 4 tests, so we have to find the 5th test. So if I knew all 5 tests, I would add them together, and since I don't know the 5th one, I'm just going to say x, and I would add them together and I would divide by the number that there are. And they're telling me that when I find this average, the answer is 78. So once I add these like terms, I get 315 plus x over 5 equals 78. And then I can multiply both sides by 5 to get rid of my fraction. So I've got 315 plus x equals 390. And then subtract 315 from both sides, you get x equals 75. So that means he must have gotten a 75 on the last test. Another way to think of it, it's the similar process, but it's just not really using an algebraic equation, is that if he had scored 78 on all 5 tests, then he would have had a total of 390 points. But when I add his tests together, he only has 315 points. I'm saying this person only has 315 points. So that means that 390 minus 315 equals 75. He's short 75 points, which is what he must make on that last test. Alright, simplifying exponents. There were 2 different videos that went over simplifying exponents. So here we're multiplying. When I'm multiplying, I'm adding exponents, because what this is a and a, that's a squared, and then 5 more. So I've got 1, 2, 3, 4, 5, 6, 7, which is the same thing as if I would have just added those exponents. Alright, this is a cubed raised to the 4th power. Remember that whenever I raise it to a power, it's multiplying by itself that many times. So that's a cubed times itself 4 times. And if I were to now, I'm multiplying, I can add all those up. That's 3a's, 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 3a's. That's 3, 6, 9, 12 a's, or a to the 12th. That's the same as if I had just multiplied those exponents. Alright, remember that in order to divide exponent, or my rules for dividing with exponents are, if I've got a, I'm just going to deal with the a's. 2 a's on top and 5 a's on bottom. Then these become 1, so I'm just left with 3 on the bottom. So really, I can just do the biggest exponent minus the smaller one, and then the leftovers go wherever the larger exponent was. Or you can think of bringing these 2 down and the exponent becoming negative, however you remember it. But I have 2 of these a's that cancel out with 2 of those, so it becomes a to the 3rd. And then if I bring this b to the negative 3rd down, so it becomes positive, I've got 1b down here, bring down 3, it's going to become b to the 4th, and I'm left with just a constant of 1 on the top. Order of operations, I am following PEMDAS, so according to that I'm going to do parentheses first. Within my parentheses though, I also have to follow order of operations, so I have some exponents. 2 squared becomes 4. Continuing with my parentheses, 8 minus 4 is 4. And then remember, multiplication and division they have the same kind of hierarchy, so I'm going to do them from left to right as they appear. So I've got 4 times 3 is 12, and then 12 divided by 2 is 6. Order of operations over here. Square roots you can treat them as grouping symbols, so you need to take care of what's inside of them or underneath them first. Negative 4 squared, that's negative 4 times negative 4, which is positive 16. And then underneath, I'm going to go ahead and multiply. I've got negative 2 times negative 2 times negative 2 because it's cubed. So that becomes negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Alright, taking the square root of 16 gives me 4 because when I square 4, I get 16. So that becomes 4, and these are being multiplied right next to each other. And then combining on the bottom, I've got negative 12. 8 minus 4 times 3 is 12 over negative 12. 8 minus 12 is negative 4. And negative 4 over negative 12 reduces to be positive 1/3. Evaluating expressions, I'm substituting these values in for my variables. So A, I'm replacing or substituting in a 2. B, I'm replacing with a negative 5. And C with a negative 3. And then I just simplify. According to order of operations, I'm going to do my exponents first. Yes, I have parentheses, but there's nothing to do within the parentheses. All of these parentheses just are helping me to see that I'm multiplying these numbers. Negative 5 times negative 5 is positive 25. And then negative 2 times negative 3 is going to be positive 6. Again, doing multiplication before I do the addition, I get 50 plus 6, so 56. And my last 3 are inequalities. So for this first one, I'm going to do down here, I've got 3x minus 12 is greater than 24. Add 12 to both sides to isolate my variable. 3x is greater than 36. Divide, and I get x is greater than 12. So again, you have to have a number line that accompanies that. Whoops, sorry. So I've got 0 here, 12 here, and it's greater than. So I'm going to not equal to, so I'm just going to do an open circle, and it's to the right. This is number 17. 18. I've got negative 3x minus 4 is less than 11. Add 4 to both sides. Negative 3x is less than 15. Divide by negative 3. Remember, when I divide by a negative with an inequality, I switch my inequality sign, and that becomes negative 5. I've got negative 5 here, and it's an open circle because it's just greater than and to the right for greater than. So both pieces are my answer, both the inequality as well as the visual graphical representation. 19, I've got 1/2 x minus 1 is less than or equal to 4. Add 1 to both sides, and I get 1/2 x is less than or equal to 5. Then in order to get rid of this 1/2, I'm going to multiply both sides by 2. X is less than or equal to 10. So I've got 0 and 10. And now since it's less than or equal to, I'm going to do a closed circle, and my arrow is going to go to the left. So the arrow to the left takes care of the less than, and then the closed circle takes care of the equal to.